Okay, I'm recording. Okay, we are at the precipice. So this week we will be migrating towards back-end web development. And so this will be the last lecture for now, at least, where we will cover front-end technologies. I would like to revisit with React later on after we have a little bit of exposure with Node and NPM, since React development will be beneficial with that knowledge, since we'll have to compile the JSX. But for today, I want to cover some general JavaScript principles that are similar in both the browser and Node. So today we will finish our discussion on browser side development, but with topics that will immediately be relevant for backend development as well. And that's going to be fleshing out this concept of asynchronous JavaScript. And so we've actually, in practice, been using asynchronous JavaScript a lot, in fact. So anytime we've attached a callback function to an event listener for the event dispatcher to execute, that's technically asynchronous programming. Every time we use the fetch method, that's also asynchronous programming, because we're waiting for the server to send back a response, and we don't want to block our code until that happens. And so here, I want to give some illumination in what is actually happening with fetch in particular to allow us to do that. And so this is a pretty critical thing to understand, simply because just like we have to use fetches to send HTTP request to the back end, well, we'll also, obviously, the web server will have its own asynchronous operations it needs to do to handle those HTTP requests and responses. In addition to that, I want to try to cover the concept of modules. Modules are very popular in Node. It's probably the dominant way that we will be able to access external libraries. And so modules are not just an artifact of Node, but it is something that's part of the general JavaScript spec. So I want to cover what modules look like in the browser side, so that we can compare and contrast when we start talking about Node for next lecture. So our objectives today are to talk about asynchronous JavaScript in the browser side, so we can contrast it to the server side. I also want to talk about modules as they appear in the browser side, so we can compare them to the server side. Okay, and then lastly, we'll probably just summarize where we're going to go in terms of our back-end journey. Okay, so for this first part with asynchronous JavaScript, I just want to go into some of the basics here. So let's see. So first, I want to talk about promises. What is a promise in a programming language, in particular JavaScript? So a promise is essentially a proxy for a value that's not necessarily known when the promise is created. It allows you to associate handlers or callback functions with an asynchronous action's eventual success value or some kind of failure reason. So this lets asynchronous methods return values like synchronous methods do. So instead of immediately returning the value, though, we wait until the method returns the promise and supply the value at some point in the future. So a promise is one of a couple states. It can have a pending state, it can have a fulfilled state, and it can have a rejected state. And you might have already seen these while working with fetch for our response objects. But we'll take and look at some actual live examples in today's lectures. Okay, so the constructor for a promise object, just so that you know what they look like, because we might not use promise objects directly. We might be indirectly using them, but we could built instances of them. The constructor is visible to us, right from the global namespace. And so here we can just invoke the constructor with the new keyword and a promise. And notice the parameter here is what's referred to as an executor function. And this executor function expects two parameters, which is a resolve and a reject. And so this executor runs automatically, and it contains whatever our code is inside of this function that gets passed in. So there's like this wrapper function that wraps around our code that gets passed in. Okay, and so these arguments resolve and reject are callbacks provided to JavaScript itself. So our code is only inside the executor. All this right here is typically handled by JavaScript. And when the executor obtains the result, be it soon or late, it doesn't matter, it should call one of these callbacks, either resolve or reject. And so the resolve callback function, if the job finishes successfully, it will result in a value. And on the reject callback function, if an error occurred, it will return an error object. So to summarize, the executor runs automatically and it attempts to perform a job. When it finished with the attempt, it calls resolve if it was successful, or reject if there was an error. The promise object returned by the new promise constructor has these initial properties. It has the state, which I illustrated before, could have the value of pending, fulfilled, or rejected, and it has a result value which is initially undefined, and it can either this value of result can either have a value or an error object. So here is kind of a state diagram that just kind of illustrates when we initially create a new promise with some executor, the initial state is pending, the result is undefined. If it resolves, it becomes fulfilled with a value. If it gets rejected in some kind of way, the status becomes rejected, and the result is the error object. And so here we can actually go ahead and see what is happening here. So here's an example. And so before we run this, let's actually kind of walk through. So here we're going to create a new promise object. We're going to pass it in this executor function. And inside the executor function, we'll set some timeout, just so there's a delay of 1 second. And then we will actually invoke to have it resolve. So we'll actually invoke the resolve function and pass in the value of done. So the two things by running the above is, one, the executor is called automatically and immediately, and two, the executor receives these two arguments, and these functions are predefined by the JavaScript engine, so we don't have to create them. So that is what allows us to go ahead and invoke and pass the value that we want the promise to essentially assign to the result state, or the result value. State is actually one of its properties. So let's take a look at this. So let's do this too. Let's do a console.log on promise so that we can see what's happening to promise immediately after we go ahead. To illustrate that, one of the nice things about this concept of asynchronous JavaScript, asynchronous functions, asynchronous operations, means that it is non-blocking. And so what that means is, even before we got a result, we were able to execute this console.log promise. And so at the stage that this console.log promise executed, it was pending. But now if we take a look at the promise, let's take a look. Now we can see it's fulfilled after 1 second, and the value is done. So this is just an illustration of how we can kind of embed asynchronous behavior into our synchronous scripts. And of course, synchronous just means that you happen consecutively, one statement after the other. And typically in sequential operations, it typically blocks and waits for a statement to finish processing and executing before moving on to the next statement. So asynchronous allows us to get a promise and with the understanding that it will eventually resolve, but allows us to move on and continue processing thereafter. Again, you can see big use case for this in terms of any kind of networked behavior where you might be waiting for a response from a server for some unknown amount of time. Okay, so that was an example of a successful completion of a fulfilled promise. Why don't we take a look at the opposite? Let's see what happens if we go ahead and define a promise, and then inside of the executor function, we'll actually go ahead and invoke the reject callback function and pass it a new error message. So here, let's go ahead and clear and paste our code. So here I will go ahead and create a promise. So we'll create a new promise, and in the executor function here, we will invoke the reject callback with that new object that says whoops, and we'll do that after 1 second. And just like before I go ahead and hit enter to execute this, I also want to add in a line of code here that will console log the initial state of our promise, just to illustrate that it's non-blocking. I mean, yeah, that this is non-blocking. And there, you see we immediately go ahead and print out a pending state, and then finally, we print out an error message, whoops, when we go ahead and hit that reject state. So that's the basic idea behind what a promise object is and how it gets handled during the execution of our JavaScript code. So promise objects themselves have a number of built-in functions that allow us to go ahead and do something in response to a promise changing from a pending state to a fulfilled state. So a promise object serves as a link between the executor, that's that producing code, and the consuming functions. Took out that example, so we will remove references to it. And the consuming functions, which will receive the result of an error. Consuming functions can be registered using methods such as then, catch, and finally. And so again, the catch and finally, the metaphor for those, you're probably familiar already with try catch blocks, but we'll still cover those. So then is probably the most common that you'll see. So effectively, what it does is it registers a callback function to trigger after a promise is fulfilled. So given this promise, if I go ahead and invoke a then, I give it this callback. I can actually give it two if I wanted to. The first one is the callback for a result. The second one is the callback, the handler, for an error. And so in this instance, we have an example. Let's go ahead and test this out. And I will explain it in the console. Let's clear this. Okay, so here we're going to just create a variable we'll call promise. We'll instantiate it with a new promise. And with this new promise, we want to go ahead and take the resolve value and pass that into this function. So big fat arrow function. We're setting the timeout. So it goes for 1 second before sending the resolve to be done. We're doing this so that there's a bit of a delay here so that you can see, and again, I'll do the same thing here. I'll do console.log on the promise here. But more importantly, we're going to register a callback to alert. And so actually, I don't know if we cut this. Okay, I'll show you what alert. Alert is actually a built-in function that will send up just an alert message inside the browser. So when this promise resolves, in response to that, the callback function will be an alert. Actually, instead of alert, let's do this console.log. And this has to be a callback function, not an invocation. So we can just pass it a fat arrow function, console.log. And then we'll just pass it promise. There it is. See, we get our promise pending, and then finally, when it's resolved, this then triggers, and that then triggers to go ahead and print out the state of fulfilled with the value of done. Okay, so I'll show you what alert. So alert is a function itself, so I can pass it as a callback function. When I invoke it, it just generates a message like so. So here, the original place, that original with what I had from the slides, just so you know, if you were to run the slide code, this is what you'd expect. Get rid of the slide too. Okay, so after a second, you had an, and now if we look at promise, inspect promise, it should also be fulfilled. Perfect. Okay, so catch is, we would use the catch method on a promise if we're interested only in errors. Then we can use null as the first argument. So for instance, with a, and change this here, change that to consoleless because that's intended to be, sorry. Okay, there we go. So the idea is that I can actually have the same behavior of a catch in my then, because then can actually take in two arguments, one for the callback for result and one for my error. Catch is just a more elegant way of defining a then where the first argument is past a null reference, so that the only thing we're passing is a callback function to handle an error. And so in the instance that you don't need to call back on a fulfilled, but you want to do some kind of response to a rejection, then it's just cleaner to use the catch. And it's more, kind of more in line with what you'd expect with a try-catch block. So the metaphor for this is more apt and readable than just passing the then method with a null reference for the first argument and the callback function for the second. But just to show you this in action, let me copy this. And clear this here. And we will see right here, I will instantiate a promise. I will assign it to promise. Inside of the executor function, it produces a resolve and a reject. We actually want to access the reject, so we're going to specify both arguments here. We will set a timeout for a second so that there is some delay, so that we can illustrate the asynchronous properties of this. And so we will invoke the reject callback function, passing a new error of whoops. And then the entire point of doing this, because we've seen this before, is to illustrate that on our promise object, we can invoke the catch method, which will bind an alert to the callback on the instance of an error. So here, there we go. Error, whoops. And then there's the finally method. So promises support then, catches, and finally. Finallys are very similar to what you'd expect from a try and catch block. So the same way that you might use them there, you could use them here. So the callback to finally is also similar to then, but in the sense that the functions always run when the promise is settled, be it resolved or rejected. So the idea behind the distinction between finally and then is if you pass the same function to both the resolved and rejected parameters. So the big takeaway here is there's three methods that promises do. However, then could technically cover the actions or behaviors for both catch and finally. It's just catch and finally contextually provide more sense. It gives a better understanding than providing empty parameters inside the then. And so with finally, let's take a look at that example. Let's clear our workspace and go into here. Oh, did not quite copy everything. Okay, there we go. So here we'll create a new promise. In the executor function, there's the resolve and the reject. We will afterwards invoke on our promise finally. Oh, actually, I didn't produce any code here. This is just an example code. Well, this will run with an error, but it gives you an idea of how syntactically it would look. So this is chaining. It's so hard to edit code in here. So essentially, I'm chaining on the response to this, a finally, which would typically do something like stop some kind of loading indicator, and then you can respond to either your result or your error that way. So it's just a good example that you can actually pass one of these functions, like finally or catch, in between some of these other functions. And I actually want to talk about that in just a moment, not actually right here. So here it is. And remember that some of these code blocks are just examples for code that's not designed to run, but to give you illustrations. Okay, so this leads me very nicely into what I want to talk about, which is what's called promise chaining. So you can actually chain these promises of these callback functions one after the other. So we can have a sequence of asynchronous tasks to be performed. And so in this instance, we will create a new promise, and in the executor function, we will set a timeout that invokes a resolve of 1 after a second. And then after that, we will go ahead and have this other function that will take that result. It will send it in as an alert, and then return an update to that result. And then after that, we will send that alert and then update that result so that it's now different. And then we will chain another then on that. And what's interesting is the result that gets passed maintains whatever modifications had happened previous to it. So as we mutate the state of results, it's reflected in each of the alerts. So again, we're going to create this promise, and we will do our actual code inside this executor portion, and then we'll just chain three then callbacks on it. And the first callback will execute, followed by the second, followed by the third, and the result gets passed in between these callbacks. And so what's going to happen is when I go and run this after a second, and so this is just illustrates how we can go ahead and handle multiple asynchronous tasks one after the other. And so this would be more or less our diagram of what is happening to mutate that state from 1 to 2 to 4. Is there any questions related to this, or so far does this concept of asynchronous programming and then being able to chain a series of callbacks towards the resolution of that promise make sense thus far? And again, this is what's technically happening in the background for whenever we do a fetch. Okay. So let's talk about returning promises. So a handler that's used in these then methods may create and return a promise. In that case, further handlers have to wait until it settles before it gets a result. So we saw earlier in this example, we were able to chain 3 then callbacks after that promise resolves, and they all happened immediately. We can put a promise as one of the returns. So notice here, after this first then, we will return a new promise that itself will not resolve until after a second. And what you'll see is there will be a delay between the resolution of this first then and this second and third then. So this is the same code, except we will go ahead and return, instead of the result, a then. I'm sorry, a promise right here that will resolve with the result value. So it allows us to define asynchronous behavior within inside asynchronous and the response of an asynchronous behavior. Okay, so again, a new promise, executor function. We set a timeout so that we get asynchronous behavior. We will resolve by passing a value of 1. Then the callback to that will be to take that result and alert it. But then we will send a new promise here, and the executor of this will be to create a new setup with that value of 1 multiplied by 2, but wait a second for that. Oh, and then we will call this and actually do a new promise. So we will wait each of these times. So there it is, 1, and then a momentary break, then 2, and then a momentary break, and then 4, and then we're done. So in each one of those instances, we returned a promise itself, which had to resolve before we can invoke the next callback. Okay, let's talk about error handling with promises. Promise chains are great at error handling. When a promise rejects, the control jumps to the closest rejection handler, and that's very convenient in practice. So for instance, in the code below, the URL to fetch is wrong, and the catch handles the error. So I'm not going to bother really running this, but it's just an illustration that when we go and we're to put in a wrong URL, the catch that's associated will go ahead and trigger. So it's what's nice about this is that the two callback functions make it very robust in the error handling practices. So promises, the promise API, so has 6 static methods. We will quickly look at all 6 of these methods, but only one of them is really used a lot in practice, but it's good to know how all 6 of these kind of work. And generally, there's a all. We say we can do promise all. We can do a promise all settled. We can do a promise race, promise any, and then resolve and reject, which we kind of have seen what those callback functions are in practice already. But it's good to understand that these 6 exist inside of the promise class. So promise all lets you wait until all promises have been resolved before invoking a callback. So let's take a look at this in general. So let's see here. We have promise all, and inside of this method, it's going to anticipate an array. Let's go back to the syntax here. So on promise.all, it's looking for an array of promises. And when all these promises get fulfilled, then we will send an alert. And so in this instance, our first promise resolves after 3 seconds, our second promise resolves after 2 seconds, our third promise resolves after 1 second. So let's see what this looks like in practice. So this essentially, this will allow us to start grouping promises together. So 1, 2, 3. And there's our alert, which all come from the collection of promises. So it actually sends all those values back at once. So this is a really useful thing to know when you're aggregating multiple, say for instance, fetches together. If you're fetching from multiple places, instead of having to do them as multiple lines, you can go ahead and do these in multiple as an array or as a collection. And so to give you a better example of that, this is actually what that would look like. So imagine you use the static method all on promise to invoke 3 different fetches. And then in response to that, you will then invoke your callback function to handle whatever data you're looking to get back. And so this is why this is probably the most common out of the 6 we'll take a look at. We will we will skip all settled, but immediately look at the race method. So it's similar to promise all, but it waits only for the first settled promise and gets its result. So essentially, it's a race to completion, and whoever wins that race is the one who gets delivered to the callback function. So let's actually look at this in source code. So here I have promise. I will invoke on promise the static method race. Just like all, it requires an array or a collection of promise objects. Each of these promise objects in the executor function has different timeouts. One is a second, another is 2 seconds, another is 3 seconds. However, race will wait for the first one to resolve and deliver that to alert. And so since that resolves as 1, we should expect an alert message that says 1. So we will wait 1 second, and there it is. And so we will ignore these other 2 because they did not win their race. You also have the option for an any. So any is actually similar to the race method, but it waits only for the first fulfilled promise and gets its result. So what this means is that if there is a promise that was rejected, then it will ignore that and wait for any of them that actually have been fulfilled. So this will be very similar, but the first one that actually completes will be a rejected promise. So to illustrate the distinction between race and any. So here we have the static method any on promise, on the class promise. We will pass an array of promises. Here, the one that is 1 second is a rejection. So the one that triggers the any should actually be this one, the resolve 1 that is 2 seconds. So let's go ahead and wait 2 seconds. 1 and 2. And there we go. And then there is a resolve and there is a reject method. Do not want to spend too much time in this. This is just an illustration that this is part of the promise API, that JavaScript pre-implements callback functions for promise, for resolve and reject. And so just for academic completeness, those are defined by promise API. Excellent, and this is a summary of just what we said before. There's 6 static methods. So all of this talk about what promises are and how they're managed within JavaScript is to bring us to the syntax we've become more acquainted with, which is async await. Now, you might have seen the promise objects as a consequence of invoking async or await. And so what the relationship is that the async await syntax is designed to make working with promises much easier and simpler. And so the general rule of thumb is this: whenever we want to go ahead and create a asynchronous function, we don't have to do all of the complexity of creating a new promise object that has an executor function that passes in a resolve and a reject callback functions, and then put our code into there. We just preface the function. We want to have that promise-based behavior with async, and it now becomes a promise-based function. So as soon as we put a sync keyword in front of a function, it now returns a promise, and the value that would normally get returned by our function will be the resolved value of that promise. So this is just a very easy way to get that implementation that I spent the last 24 slides illustrating how it works. And so that is what's happening under the hood every time we call async. And so to illustrate this, let's go ahead and actually run this code. Okay, and I got one there. And you see there, I have a promise. And in fact, run this again. So you can see I get these, and I actually get that promise object. So this is just highlighting the fact that async wraps this return statement as a into the function that is wrapped around a promise object. See, if we wanted to, instead of just returning 1, we can also go ahead and return promise.resolve, that function, that the static function that we had mentioned previously. So essentially, this is what's happening again under the hood. This is the same result that we got here, although we do not have to know about having to invoke all of this. We can just worry about returning this thing whenever our asynchronous function is done. It will effectively resolve to have a value of 1 in its promise, in its fulfilled promise. Okay, let's move on. Okay, so we talked about how async allows us to essentially have us define a asynchronous function which wraps in a promise. So let's talk about what await is. Await is the keyword that we can make on the particular statement that we might want to wait until the promise settles and returns its result. So the nice thing about the await keyword is that this is the thing that will generate the promise. It will allow for our function to have a sequential block of code that will wait for that promise to resolve to a fulfilled state before it executes the next statement. And so the nice thing about this is it allows us to have asynchronous JavaScript produce sequential-like behavior, but it's still not blocking because this function itself, its execution pauses at this line where it waits, and it will resume and only resume after that promise settles. So other functions can then be free to be executed by the JavaScript engine. And when that promise is resolved, then this function wakes back up and finishes out the remaining amount of code that it has left. So in this case, it would be to go ahead and print out that result or alert that result. So let's take a look at that. Let's clear this. And so here in the synchronous function called f, it will generate a promise that has executor function of time out of a second. And do we have an await? Oh, yeah. We will then await for that promise to resolve. So here, the idea here is we're going to call the await keyword here and wait a second for that to resolve before sending this alert. So wait a second, and then that's our alert. And so this is what's happening. This is what's happening every time we have a fetch method where we're ahead of time prefacing that function with async, and the part that does the fetching we do an await on. So you'll notice in the lab that there are oftentimes functions that have this async await keywords applied, the async to the function, await to the particular method that's going to resolve a promise. This is the logic behind that. This is an explanation of what you're seeing when you encounter that. So it's kind of important just to have a basic understanding of that. And so, yeah, this is the takeaway. Fetch is async, it's promise-based. In front-end development, promises are often used for network requests. Fetch is the method we use for such requests. And so now you know what's happening when we use those fetch commands. Excellent. So now let's move on.